Hey, hello. Turns out there is a live stream today. Welcome to day 9 of Advent of Code. I had some last minute changes to my plans, and it turns out that this time slot has opened up again. So I'm back, and we're going to dive straight into day 9's challenge. So here we go. What does it say? These caves seem to be lava tubes. Parts are even volcanically active. Small hydrothermal vents release smoke into the caves that slowly settles like rain. If you can model how the smoke flows through the caves, you might be able to avoid it and be that much safer. The summary generates a height map of the floor of the nearby caves for you, my puzzle input. Smoke flows from the lowest point of the area it's in. For example, consider the following height map. Okay. So it's like one of those contour maps that you see. So it's a bird's eye view, right? Each number corresponds to the height of a particular location, where 9 is the highest and 0 is the lowest. Your first goal is to find the low points, the locations that are lower than any of its adjacent locations. Most locations have 4 adjacent locations, up, down, left, right. Locations on the edge or corner will have 3 or 2. Diagonal locations are not adjacent. Again, important to pick up on these things. In the above example, there are 4 low points, right, that are highlighted. The risk level of a low point is 1 plus its height. In the above example, the risk levels of the low points are 2, 1, 6, and 6. Cool. The sum of the risk levels of all low points in the height map is therefore 15. What is the sum of the risk level of all the low points in my height map? Okay, so that seems relatively straightforward to do. What I'm going to do is pass this into a grid again. Again, is this the best way to do it? Not necessarily, but I think it's going to work out well. So first, it's going to be that dimension, and then for each item in data, for each line in data, we'll call it a row. We're going to say that grid I, so we do need I, is going to be, oh no, I don't need I, because this is a, no, I do need I, is going to be an array of the length of the row, and then for each value in the row. I'm not even sure I can do that. Can I range over a, I can range over a string. Yeah, I'm pretty sure I can range over a string. J is going to be string conv.a2i v. Now I have a feeling that I can't actually a2i v because v is going to be a char or a rune or something. Yeah. So I need to turn that into a string. I need to do an error check here. And error needs to be declared. Use of package log without selector. Oops. Okay, so that seems reasonable. So the way I do this is I just loop over, check every spot, and then for every spot check its other spots, and so on. For example, I can see right here that there's a spot on the edge of the map. So we need to be a little bit careful with our edges. We're just going to say max x is going to be length of data, no, max y is length of data, and max x is going to be length of data 0. Cool, so for y equals 0, y, I think I have a shortcut for that. Y less than len grid, y plus plus. For x equals 0, x less than len of grid y. what do? We check all 4 directions. So current value is going to be grid yx. I always do my indexes to 2D arrays y and then x. It's just the way I do it, and I know how it works, and I never run into problems because of it. So up, down, left, right. Okay, so we'd start with up. Up is going to be y minus 1. We'll call it, it's not actually dy, test y, py. If y is greater than 0, then we will test for y minus 1. If grid y minus 1 x is less than current, we continue, which seems right. And then this is if y is less than max y minus 1, and grid y plus 1 x is less than current. So we're just saying if any of its adjacent values is less than itself, then it's not going to be the smallest in its local area, so we can skip it and go on to the next value. So we do the same thing, but this time with x. If x is greater than 0 and y x minus 1 is less than current, continue. If x is less than max x minus 1, do the same thing there and continue. Otherwise, if we get to this point, this is a smallest value. So risk is going to be 0. So we just say risk plus equals value plus 1. At the end, we print out our risk. It should run, it shouldn't crash. 1508. I'm happy with that, I think. Oh no, okay. Oh no, 1 plus its height. Okay, I'm gonna run it with the test data. Actually, it's a string, isn't it? Okay, so did I skip an instruction somewhere? In the above example, there are 4 low points on the map, all highlighted. 2 are in the first row, 1 is in the third row, 1 is in the bottom row. Did I just have a mistake in one of my checks somewhere? Okay. What's a couple of ways we can check this? We can go, let's see if we can print out the grid. So we print out the current number. Here we print out a new line. Let's do this in here, because then what we can do is here we can look up some, let's see, we can look up we can print it in like bold red or something. Let's take a look. I want the sequences. Okay. Okay, CSI 1. I also want red. Set foreground color. 9, apparently. Let's see if I can make this work. So 1m, how do I do multiple things? Maybe I can just do this, 5, 9m. Nope, okay, forget it. I'm just gonna do this. Okay, I don't know how to make it print in color. Okay, so that's printing out all the spots. That's good. So this is just one of those really weird terminal things that I kind of discovered at some point and am now burning all my time on. But as you can see, I'm printing in bold. This is a way to tell your, those sequences are a way to tell your terminal to print bold or in color or things like that, except I messed up the color command and I couldn't figure out how to do it. Oh, it's 3859, maybe? Oh, there we go, look at that. Okay, this is a little bit of a detour on my way to solving this thing. So now I'm gonna do this with the original data set, just to see what's going on here and why I am not getting the output I expect. So hopefully that resize is a little bit off, but okay, so that still fits on the screen, I think. Okay, that fits on the screen, so we'll leave it like that. Okay, so the 9. Okay, I made a mistake with equals. You can see in the very first row here, that 9 there is right here that I'm selecting on the first row. It's showing up as yeah, it has to be strictly less than. So if that value is less than or equal to, then it doesn't count. It has to be strictly smaller than everything else. That's what I did wrong here. And our number is 478. So let's go and take a look at that. 478. That should be correct. Right, and now I'm quite far behind, but that's okay. Part 2. Next, you need to find the largest basins so that you know what areas are most important to avoid. A basin is all locations that eventually flow downward to a single low point. Therefore, every low point has a basin, although some basins are very small. Locations of height 9 do not count as being in any basin. The size of a basin is the number of locations within the basin, including the low point. The example above has 4 basins. The top left is a basin. Okay, a basin. So a basin is any larger area that flows to a single point, right? The top right basin, size 9. Wait, what does it say? Locations of height 9 do not count as being in any basin. The middle basin, size 14. And the bottom right basin, size 9. Find the 3 largest basins and multiply their sizes together. Find the 3 largest basins. In the above example, this is 9 times 14 times 9, which is that. What do I get if I multiply the largest basins? Now, my only concern with this is that multiple low points could belong to the same basin. So how can I mark how do I mark basins? I'm sure what we can do is we can start with the low points, right? We start with the low points, and then we start with the low points, and then work our way backwards until we reach 9s. Actually, is it basically just everything that's bounded by a 9? Because doesn't every point eventually flow, every point will eventually flow to an endpoint, right? And if you look at the examples here, every basin is surrounded by 9 because only 9s can not belong to a basin. Every 8 will still belong to a basin. So in fact, what we could probably do here is I'm gonna not make this bold, but I'll still make it red. But what I'm going to do is here I'm going to say if cur is 9, we're going to set it up so it prints it bold, which was 1, and I'm going to set it up to print it in, let's say, green. Shall we say green? 5. Well, let's just do a different color. 9. We'll do 10. See what color that is. And then we just need to reset everything. Okay, so every let's do a different color. Okay, apparently I can't do different colors other than red for some reason. I can do red. I just can't do other colors. Oh, there we go, blue. Blue's not the best color actually, but I'm gonna make that blue. I'm gonna make this red. So we could even visually identify the 3 largest, but what we do, right, is we loop over the whole array. And how do we find out, how do we identify the regions? That's the only problem. We fill, right? We fill every basin with a different number. So if it's a 9, we turn it into a -1. And then anytime every time we run into a number that's not a 9, we space fill it. We do like a breadth first thing to fill that area with a different number. Yeah, let's do it that way. So, okay, I'm just gonna need to readjust this. I'm gonna make a grid. Should we make a second grid? Let's just let's just loop over the grid. Let's make a second grid. Put grid 2. And we will do this. I'm going to make this a little bit bigger again, but I just need to readjust my screen after this. Give me a sec. Okay, that seems okay. Cool. So we're going to make a second grid, and we're going to loop over the first grid. Right, we're going to loop over the first grid. If the first grid in this spot is a 9, then this is easy. In the second grid, the same spot is going to be a 0. We'll make it a 0. You know what? Let's make these strings so that we can print a wider range of values. So we'll make it hash, and that's a continue. Otherwise, what we do, we also say if grid2yx is not an empty string, which means we've already done this square, we also continue. This is going to be important later, because what we're going to do is we're going to loop over the first grid, and every time we run into a 9, we're going to mark it as a wall. Every time we run into something that's not a 9, we're going to, hello there. Good to have you join my stream. Yeah, so every time we run into a 9, we're going to mark it off as a wall. And every time we run into something that's not a 9, we're going to explore out from that region until we find all the 9s around it and then stop. Which means we need a way to like do a queue of some kind. So this is a little bit annoying, but we're going to say point is a struct with xy points. We have a queue of points. And then the queue, it's going to start off with this current position, which is xy. I wonder if I have to have that extra point in there. Maybe I don't. So from the point, we branch out and we check the exact same way we did before. We use this sort of four-way check for len q is greater than 0. So while the queue is not empty, we're going to check the current spot. If so p is q0, q equals q, we pop it off the queue, basically. And then we say if the current spot is not a 9, then we call this we won't call these strings, we'll call them runes, just so that it's a little bit easier to, runes are like chars. So we'll call our name is A. We start with A. We say that that point is going to be part of the basin called the current one, which is A. This name needs to go out here. because at the end of this, we need to say name to turn it to the next letter. I feel like I could have done this by hand by now, but we'll code it up because it is a coding challenge. And then if that is, in fact, we don't even have to do that check because we already know that the first one is not a 9. And what we can do here is this. If it's not 9, then we push it to the queue, right? Q equals append q x y minus 1. We do the same thing for all the other ones. I think this challenge was quite interesting because they made it sound like you had to do these kind of flow. You had to follow the flow of the lava, or was it lava in the question? Yeah, they made it sound like you had to follow the flow of the lava. But if you sit back and think about the problem for a little bit, it doesn't actually, the problem doesn't require you to actually do that. I'm just gonna make sure I've got all these minus ones, plus ones around the right way, or else I'm gonna make a whole lot of mistakes. Okay. So we're just gonna run into some type issues. Cool, and we've got another thing here. Right, more type issues. What is an empty rune actually? I don't know. It's probably 0, right? Okay, made a mistake somewhere because I'm not. And we have to. Oh, okay. We do have to check if grid 2. We do need to check. Otherwise, it's just doing itself over and over again, the same values. We do have to check here that doesn't equal 9 and grid 2 y minus 1 x is 0. So as in we haven't checked that square yet, then we can add it. If we've checked the square, the cell, then we don't need to add it back to the queue. Right? This is why I said before I had to make sure my plus ones and minus ones were correct. Okay, so that printed that out. What we're going to do now is I'm going to print out the same thing, but here instead of printing out these values, I'm going to print out grid 2 yx. Which means we get to see, hopefully, the basin areas. That is really strange. Why is it? Okay. Right. I think I need to print out characters. maybe? Characters? I mean, the idea is there, but something is coming out wrong. Maybe I can just print it as a string. Okay, I'm just getting some really weird numbers in here for some reason, and I don't know why. I started off at A. Name plus plus. Okay. I mean, it's working. It's just not working. Oh, we've got A, B, C. Oh, no. Okay. Hang on a minute. I'm not checking. It's not overwrite. It's not doing my Okay, no, the algorithm's just wrong. Ah, the continues. The continues are wrong. I don't need the continues. I don't need these continues. That's what's wrong, I think. This is going to break my terminal. The idea is there. But I am not counting my grids correctly. Ah, I know why. These are all meant to be p dot. Oh, that's kind of poor. So I'm just going to replace all these. Okay, let's give that a go. Okay, that looks a little bit more promising. At least we're not running out of values now. And it seems to be space filling properly. So I'm just going to make that a little smaller so I can see the whole screen like before. And let's take a look at this beautiful, beautiful chart. Okay, it's not starting at A, which is a little bit disconcerting, even though it should be. Oh, notice it is starting at A. The map is just a lot bigger than I thought it was. Is it really that big? Wow, okay. All right. I had no idea it actually stretched across multiple screens. I thought it was just one screen wide. So it starts. So my terminal's a little messed up here, but it starts here and it goes down from there. Yeah, I mean that looks fair now. Weird symbols aside. So what we're gonna do here now is then we're just going to, oh, sorry, my window is still a little bit big. Hopefully that fits correctly on the screen. Good. Now we just have to count every single one of those. So we're gonna do a count. Is a map of rune to int. We're going to loop over the whole grid of grid 2, which means we need this loop for grid 2. And we're going to say simply that when you encounter something that's not a hash, ooh, that's not a hash. Actually, did any one of my other symbols end up being a hash? Did we end up reusing hash somewhere? Okay, just because I'm afraid that I might have reused hash, I'm going to use the number, let's say 9 back here, just because I know that 9 isn't being used as a number, because the number 9 in ASCII is smaller than capital A. So this way I definitely won't run into any problems with that. So we just say if the value is 9, we pass and we continue. Else, the value is going to be the value in the grid. If it's already in the map, if counts of that value is not 0, we continue because we've already counted it. Otherwise, we count it. And to count it, we do, oh, do we have to do the exact same thing? No, we can cheat here. We can cheat here. Oh my gosh, we don't have to do this as a grid. I can just turn it into a string. Can you turn an array of, how do you turn an array of runes into a string? Can I just do that? Let me just grab this. Does this run? And does it do what I want it to do? Apparently it does. So we can actually just go strings.join. Well, okay, big string equals empty string. We loop over grid 2. We just say big string plus equals string row. So I just want to see that that works. And it does. In which case, then now to do the counts, all we have to do is, oh, I didn't even have to do it like this. I'm just being silly. I didn't have to turn it into a string. I could have still done it with the loop. You know what? It's probably more instructive to do it as a loop. I'm just being silly. Otherwise, we just add it. We just increment the count. We just increment the count. It's been too long. It's been 40 minutes, me doing this. We print out counts as well. Cool. We find the biggest 3 counts in this array. So the biggest 3 counts will be we can just sort it. My brain is fried and I can't do this anymore. So for every value in counts, we're just going to add it to the array. We're going to sort the array, and then we print out the array. We're going to get the last 3 numbers: 106, 107, 117. I just did it off screen. I'm getting this number. I just did that on my calculator off screen. So if this isn't it, I am going to be really sad. But I think it's going to be okay. Yes. Okay. Oh man, I want to see your ratings. So by the way, if on the screen it doesn't tell you what your rank is, it means you finished past 1,000. Yeah, this was a really horrible day for me. I think the shortcut that I came up with, right, to find the borders and then just count the spaces, that's probably the right way to approach it. It's just that I had a lot of problems actually implementing that. Oh man, I had a couple of things I wanted to talk about, but I can't remember what they are anymore. I got tripped up with the definition of the problem at the start as well. It had to be strictly less than, right? Every side had to be strictly less than. If it was equal, I think it doesn't flow. Maybe I wasn't clear about it. But I guess it makes sense, right? Like does water flow on a level surface? I guess it does. Yeah. I missed the fact that it had to be strictly less than for it to count as a load point. So that was my first mistake, which cost me an iteration. And then for the second part, yeah, I seriously was considering marking the flow, and it was just that insight that because every number will flow somewhere. Actually, is that even the case that every number will flow somewhere? What if you have a whole set of 8s? If you had a plateau, it's possible that they actually don't flow. I'm not sure how to model that in this anymore then. So that would be an interesting edge case, right? If you had a plateau of 8s surrounded by 9s, is that really a basin? It makes sense to call it a basin. It'll be that's interesting, but I didn't run into that issue. Yeah, so for the second part, marking off the boundaries of each basin and then just counting the sizes of each basin. So that was an interesting way to do it, and I did it that way. These border checks are really annoying because they're just so long, the conditionals, and so unreadable. I know what I did in the past. Last year when I had grid problems like this in JavaScript, I did a really I just did a hack where I put the grid as the grid was a map, and I ended up doing basically like this as like indexes into a map, And the nice thing about maps in JavaScript is that if the coordinate doesn't exist, you get undefined back. Undefined or null? I think undefined in this case, right? Which means if you ended up putting like -1, 2 in, for example, because you were checking one past the end of a border row or column, you just get undefined back. It doesn't crash or anything. And that makes it a lot faster to run. Whereas in this case, because I have to use a proper array, technically it's a slice, but it's an array. I had to do all these out of bounds checks, which again are just annoying and a hotbed for mistakes. So something else to kind of be aware of. And then like using these ANSI escape sequences to print out in color and bold and all that stuff. It's just something I find fascinating. And I saw an opportunity to use it to make it easier to read, and I did it. Cost me a couple of minutes to look it up, but it was fun. Yeah, these are called ANSI escape sequences. They're really fun to look at, to use if you do terminal stuff quite often. So yeah, worth knowing a little bit about them. Other than that, yeah, it was a interesting puzzle. Yeah, these grid things, they do my head in. So thanks for joining me today. I'm just gonna call it here, and there will be a stream tomorrow. So hope to see you again next time.